starting with lesson 5.1. They call it rational numbers. Rational numbers. Now, they give you a similar box, and the big specific box is rational numbers. Rational numbers. Okay? Some rational numbers are integers. Okay? Some integers are whole numbers. We went from the broad to the specific. I'm going to go ahead and write it a little bit of a different way. Rational numbers might include 0.6 with a repeater. Rational numbers might include -4, 3.25, 0, 1, 2, 18. All of those are rational numbers. Okay? Of that bunch, the integers are -4, 0, 1, 2, and 18. Of that bunch, the whole numbers are 0, 1, 2, and 18. See how different things disappear as we get more and more specific? Okay? So just to kind of give you, this little sketch here is helpful for me. By definition, an integer is a quotient of two numbers. I don't really like that definition, but that is the one that they give us. So I'm going to practice that with you. Oops, I forgot to keep my fraction down here. 3.25. Okay, let me just keep going here. Okay, let me open this up. So, by their definition, rational numbers are quotients of two numbers. I thought I was correct the first time. Rational numbers, simply put, is it a quotient of two integers? Two of those specific items. So, example 1A. Is 7 the quotient of two integers? 7 divided by 1, or 35 divided by 5, right? So by definition, 7 indeed is a rational number. Okay? 7 indeed is a rational number. B, the same kind of thing. -10 is the quotient of two integers. -10 divided by 1, or -20 divided by 2. This is the proof that these numbers are rational. Okay? Rational, not necessarily integers, not necessarily whole numbers. Okay? Letter C, 5 3/4. 5 3/4, which I can just convert into an improper fraction, which is also the quotient of two integers. Okay? D, another fraction, which is super easy. -3.5, convert it to an improper fraction. That improper fraction includes Integers. Okay? So by definition, we have just determined that all of these numbers fit the bucket rational. Okay? In Algebra 1 and Algebra 2, you will learn about irrational numbers, or numbers that are not the norm, normals that are imaginary. These kind of strange things fit into that bucket. And you're not learning about any of those right now, which is why you're thinking, why do we have to call something rational? Because there's another side of the numbers. Okay? All right. What if I did, let's see, 1 divided by 3. Okay, this is my example. 1 divided by 3. What if I actually carried out the division in a calculator? 1 divided by 3. Look at that. Repeat, 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 repeat. That's still considered a rational number. Okay? That is still considered a rational number. All right? So, it's still rational because 1 divided by 3, they're both integers per the definition. Now, I know a lot of you are thinking there's no point to all this, but believe me, there is. These are building blocks for your math career. Okay, example 2. What if I asked you to write 3/8 as a decimal or 5/11 as a decimal? The procedure for converting a fraction into a decimal is to divide the numerator by the denominator. And you could all easily perform that division, right? 3 divided by 8, you end up with 0.375. But let's do 5 divided by 11. Throw some digits in here, and we're going to end up with 4, 5, 4. Is anybody starting to see a trend? Okay, that is a repeater. So instead of writing 4, 5, 4, 5, 4, 5, 4, 5, you write what repeats, which is the 4 and the 5. Okay, this is where the repeating began. Write what has repeated with a line over it. Okay? Your calculator might, some calculators show it. Yeah, they do. They just keep showing it. Some of them will round the last digit. Some of them will round the last digit. Okay, it'll be really big, really long, but it rounds. Okay, let's do checkpoint number 2. -2 divided by 3. -2 divided by 3. You could easily plug that into your calculator, but for sake of argument, a -6, bring down your 2, bring down your 0. 6 again. We have started repeating right there. Okay, you could do it a third time just to verify, but the answer is -6/10 with a repeater. 6, 6, 6, 6, 6, 6, 6, out into outer space. Okay? Checkpoint 4 is 29 divided by 80. This is to find the decimal. Okay? So 29, 80, start plugging in. Move your decimal up. So 3, 2, 40, 50, bring down a 0. 80 goes into 500, 6, 480. Bring down another 0. 2, not done yet. Here we go. And 5. Okay? 0.3625. Do you guys remember how we changed fractions to the lowest common denominator in order to convert fractions, and I said I simply like to divide because it's easier. Well, they actually address that issue right now in example 3. Okay, rodents. Of the 50 critters living in the Grand Canyon National Park, 20 of them are rodents in the order Rodentia. So 20 out of 50 are Rodentia in Canyonland. In Badlands, 24 out of 54 are Rodentia. Okay, do you see what they're doing? They're comparing Canyonlands rodents with the Badlands rodents. So they're doing rodents over mammal and rodents over mammal. In Canyonland, out of the 50, 20 of them are mammals. Reduce it, you got 2/5. In the Badlands, out of the 54, 24 of them are mammals. Divide the numerator by denominator and see what you get. 20 divided by 50, 20 divided by 50 is 0.4, otherwise known as 40%. Would you agree with me that 0.4 is 40%? 24 divided by 54 is 4. So 0.4 with a repeatant, which is approximately 44%. Okay? Because I looked at the next digit. This one is 0.40. This one, if I carried it one more digit, would be 44. Therefore, Badlands has a larger percentage of creatures that are rodents. Okay, writing terminating decimals as fractions. So writing normal decimals as fractions is what our next thing is. Okay, so if you are given a decimal like that, read that to me without saying point. Go ahead, Haley.
16,000.
She says 16 hundredths. By reading it without using point or dot, you actually read its decimal value. Okay, 1600, or you read the fraction. From here you ask yourself, can it be reduced? Definitely by 4. 4 over 25 is the reduced form. Okay, 16 hundredths, easy to see. How about this one? How about this one? Negative what? 6 and 2 what? 2 hundredths, which reduces to negative 6 and 1/50th. Okay, so speaking it without saying point or dot is generally going to get you to this position here. Reducing it is the last step of the problem. They give us a couple of examples there in example 4. Dot 7, which is read 7/10, didn't even require reducing. Negative 3.05 is negative 3 and 5 hundredths, which they reduced. Okay? Okay, here's the big one.